Assalamualaikum and salam sejahtera. Today I will continue topics on column direct load part 1 examples. Example 1, determine the critical load of aluminium tube that is 1.5 meter long and has 16 mm outer diameter and 1.25 mm wall thickness. E equal to 70 gigapascal. This is the thickness of the tube and this is the outer diameter. To determine the P-critical, you need to use Euler formula. This is the initial formula for hollow shaft. Substitute the radius outer 8 mm. This is the inner radius. Radius outer minus thickness of the tube. Substitute these two data to the initial formula. Get the result for initial. Substitute to the Euler formula. The result for P critical is 487 Newton. Second example, a A36 steel W200 times 46 member shown to be used as pin connected column. You need to determine the largest axial load it can support before either begin to buckle or the steel become yield. This is the x-axis, this is y-axis with length 4 meter. For calculation, column x-section area and moment initial are, this is the area value, this is the initial at x-axis, this is the initial at y-axis. By inspection, buckling will occur about the y-axis. Apply the Euler formula or the buckling equation. We have P critical 1887.6 kilonewton. When fully loaded, average compressive stress in column is stress equal to P critical over area. This is the stress critical value. Since this stress exceeds the yield strength given 250, the load is determined from simple compression formula. 250 equal to P divided by area. The new load equal to 1472.5 kilonewton. Example number 3. Refer to textbook page 620 number 10.10. Determine the critical load of round wooden dowel that is 1.2 meter long with diameter 9, 12, use E equal to 11 gigapascal. Using your Euler formula, the I for hollow equal to pi over 4 C4. Substitute the I value to the Euler equation. You can determine the value is 24.3 Newton. For diameter 12, the I value is 1017.9. Substitute the initial to Euler equation. The P critical 76.7. If the diameter increase, the P critical also increase. Example number 4. Refer to the textbook. Determine the critical load of steel tube that is 5 meter long as 100 mm diameter and 16 mm wall thickness. Use E 200 giga. This is the Euler formula or equation. This is the initial formula for hollow or tube. This is the radius for outer. This is the radius for inner. Substitute these two data to initial formula. This is the initial result. Substitute to Euler. Can determine the P critical equal to 305 kilonewton. Example number 5. Determine the critical load for the brass rod. This is a brass rod. The length is 1.1 meter. This is the dimension for square column 20, and this one 20. Second question, you need to determine the D for which the aluminum rod will have the same critical. You need to determine the D for aluminium if the load brass determined transfer to the aluminium. So this is data for brass, and this is data for aluminium. This is E data. This is the density data. Number 3, you need to determine the weight of aluminum rod, percentage of the weight of the brass. Okay, this is a formula to determine the P critical for brass. This is the initial formula for brass, BD3/12. Substitute the I for brass at Euler formula. So the P critical for brass is 13.06 kilonewton. Substitute the P critical value to the aluminum rod. Initial aluminum formula is D power of 4 divided by 12. This is the formula to determine the D, and the D value is 22.9 mm. So when the same load applied to the aluminum, the D is bigger compared to the D brass. This is the D for aluminium. Why? Because brass is stronger compared to the aluminium. The weight percentage for aluminium over brass, this is the formula. Substitute all data from the brass and aluminium, substitute to this formula, you get the percentage of between brass, aluminum and brass, 40.6%. Example number 6 is a 5 strap consists of running tube as 32 outer diameter and 4 mm thickness using E70 giga, safety factor 2.3. Determine the load PO for each support condition. This is the question from textbook. First condition is pin, free, fix, pin, fix and roller. So from Euler formula, you determine this value, pi power of 2 times E times I. This is the initial for hollow. Substitute the value to this equation. This is the P critical formula. Change to P available, so divide by safety factor. This is the P available formula. Refer to figure of load applied at the column. The N value for first figure is 1, so the L effective 0. Figure number 2, the N value is 2, the L effective 0. The third figure, the n value is 0.5, so the L effective 1. Number 4 figure, the n equal to 0.7, the L effective become 1.4. Number 5 figure, the n value is 1, so the L effective is 2. Substitute the L effective to this P available formula, you can get all the available P available for different type of column. In this slide, there are 5 exercises. So using your lecture note, textbooks and tutorial, I hope you can do by yourself this exercise, so that makes you confident for your midterm and final exam. Thank you.